Okay, let's do one more video on 11.5. Okay, last time I kind of went through a proof of the alternating series test. Now I'm gonna put down the general proof here. Read your book. Let you go through your book on that one. I did one that had numbers in it. Thought it'd make a little more sense. But the general theorem is if you got a series, n equals 1 to infinity of a minus 1 to the n, and it can start n plus 1, wherever you want to start, just as long as it's an alternating series. And if these three things happen, if Bn, the limit as n goes to infinity of Bn goes to 0, that has to happen or you can just quit. And what we got, that Bn, these guys are positive, and Bn plus 1 is less than Bn. So the insides go to 0, the insides without the negative are positive, and they're decreasing. If all these things are true, and again, these are positive, we make them negative by putting this -1 on it. If it's inside, if the sequence without the plus minus goes to 0, if the sequences are positive and are decreasing, then we know the alternating series converges. Converges to what? We don't know. So what we saw last time was a little strange, that if you had summation 1 over n, this diverged. But if you had a series a minus 1 to the n, 1 over n, that converged. Okay, that's a little strange. So again, read your book on the actual proof on the alternating series test. I'm going to go through an example and kind of show you on the alternating series, it's really easy to get an error bound, which was I like alternating series. If I get an alternating series, it's really, really easy. I can tell if it converges really quick and I can get an error bound. Let's look at a series that we're used to. N equals 1 to infinity of a minus 1 to the n plus 1 of 1 over n. Let's see what that looks like. So I'm going to write this. So S infinity, which means do the whole thing, would be first term's a 1, and then you get a minus 1/2, a plus 1/3, a minus 1/4, a plus 1/5, a minus 1/6, a plus 1/5, a minus 1/8, then you just keep going forever. Okay? Now, let's suppose we're going to approximate this guy by S4. What would that be? That's going to be 1 minus 1/2 plus 1/3 minus 1/4. Okay? Now, what's a remainder? Remainder, so this is what we're going to use, and then this is going to be our remainder. And this is S4. Okay, so we're using S4. Let's see what our remainder is. How bad did we do? So remainder is going to be, sorry, that's not SR4. I went too far. That's S4. This is R4. It's the one next one. Okay, so R4 is going to be 1/5 minus 1/6 plus 1/7 minus 1/8 plus 1/9. Now, let me look at this. Let me rewrite this guy. So R4 can be written as 1/5 and then plus a minus 1/6 plus 1/7. That's a minus number. Then I can take the next two, plus a minus 1/8 plus 1/9. That's a negative number. And I can keep doing that, and I can make it where you got 1/5 minus a number, minus a number, minus a number. Why do I know about the whole remainder? It's got to be less than the 5th, because I'm taking the 5th and taking a bunch of numbers off of it. So I know my remainder 4 is less than 1/5. So the general theorem, if you have an alternating series, if I go out 7 terms, my error is less than the 8th term. So read through your theorem in your book, but to get all the details. But if I got an alternating series and everything works and it converges, the error is the less than the term after where I quit. Let me do one example, and I'll stop and give you some homework. So grab one out of your book, and it is summation n equals 1 to infinity of a minus 1 to the n over n times 5 to the n. And they want your error on this guy to be less than 0.000, three zeros and a 1. Okay, so let's look at that. First, does it work? Okay, you're going to rewrite this as being n equals 1 to infinity. You got a minus 1 to the n. It is alternating. And you got n 5 to the n. Are all these guys positive? Shown they're positive. As long as n's are positive, so this guy's positive. Is it decreasing? Well, every time you stick an n in, the bottom gets bigger. So the bottom gets bigger, the whole thing gets smaller. So it's decreasing, positive, and do these guys go to 0? Yeah, it's going, the bottom's going to infinity, so it's going to 0. So this is, limit's going to 0, they're positive, and they're decreasing. So I know by the alternating series test, this guy is going to converge. Converge to what? I don't know, we'll probably never know. But let's get an error on it. So if I use S7, so it means use 7 terms of this guy, I know my error is going to be less than S8. No, it's not going to be less than S8. It's going to be less than B8. Okay, so if approximate by summing up the first 7 terms, my error is less than B8, and that will be a positive number because I'm not, there's the negative piece, that's a positive number. Okay, so let's see how big we have to go. So what I got to do, I've got to figure out what this piece is here. I'm going to make 1 over n 5 to the n. I got to make that less than 0.0001. Okay, so I got to find an n that makes that happen. Okay, so I plugged this earlier into the calculator. Sorry, in class I don't like to do that. I like to work through it, but on the videos I don't know what to do. It's just not near as good as being in a regular class. So I plugged that into a calculator, and I found out when n was equal to 5, this thing right here was equal to, not equal to, close to 0.000064. When I plugged in 4, it wasn't smaller than that guy. But once you plug in 5, you got this one, and that's less than 0.0001. So when I plugged in 5, I got the Bn. So I got Bn is less than your error. Okay, so B5, sorry in this case, so B5 is less than your error. So that says that all I got to do to approximate this guy is say n equals 1, 2, do I go to 5? No, I'll go to 4 because my error is less than the next guy. 1 to 4 of a minus 1 to the n, 1 over n, 5 to the n. If I just sum up the first 4 terms, it'll be close enough, it'll have an error, back up, then S infinity minus S4 in absolute value will be less than 0.0001. So if I only use 4 terms to approximate this guy, my error will be less than 0.0001. Okay, so again, alternating series are really good because you can tell real easy if they converge, and you can error bound on them really, really quick. Okay, so we're going to stop there, and that's 11.5.